Okay, so today we are going to go over the third and final loop that you need to know for this unit, and this is called the for loop. Now, just a reminder that normally all three loops can be used for the same scenario. It's just some are better or worse. And when I say better or worse, I mean more or less efficient for different tasks. Now, the for loop is different from the while and the do while loop because in a for loop, you know exactly how many times that loop is going to run. All right. Meanwhile, in a while and a do while, maybe it depends on the user input. Maybe there's some sort of factor that will change depending on how the program is being run, but you don't know how many times a loop will run for the do or the do while loop. Let's take a look at this for loop over here on the screen. All right. There are three different sections to a for loop. The first section is when you initialize a variable. This variable is going to be your counter. All right. Unless there's a specific use for this variable, you can just name it something generic like I. Now, normally we initialize I at 0, but you could initialize I to be whatever you want. But in this example, I initialize I at 0, and then I have a semicolon to separate it from the second section of my for loop, which is the conditional. Now, the conditional decides when you leave your loop, or rather, the conditional decides how long you stay in your loop. In this loop, I am going to keep running the contents over and over and over as long as I is less than 25. Now, the third section, again separated by a semicolon, is the increment or the decrement. It's where you decide for each iteration how much you are increasing I by. So over here, for each iteration of my for loop, I am going to keep increasing I by 1. So this loop is going to run 25 times from when I equals 0, increasing by 1, all the way to when I is equal to 24. And then when I equals 25, it is going to be too large because 25 is not less than 25. This will return as false. And then I will leave the for loop, print this one last statement, and I will be good to go. So as you can see, I am running the same contents of the loop, hello there, tab I, starting at 0 all the way until 24. Now that does not mean that I ends as 24. I ends as 25 because that is when the loop is over. That is when it is too large. So we print out that last statement, loop over, I is equal to 25, goodbye. So a for loop in this situation will always run 25 times, and you can change any one of these you can change any one of these three sections where you initialize it, your condition, or your increment in order to adjust that. So let's do a couple of those right now. If we start I at 10, then this loop is going to run only 15 times. Okay, it's going to skip 0 to 9. If we, if I start I at 0 again, but instead of incrementing I by 1, I increase I by 4, then it's not going to go 0, 1, 2, 3, 4, 5. It's going to go 0, 4, 8, 12, 16, 20, 24, and then it's going to go to 28, and 28 is going to be when it's larger than 25, so that's when we're done. Okay? I don't always have to increase it. Sometimes you can choose to decrease it. So if I go I minus minus, I'm decreasing it by 1. Okay? And then in this situation, again, I'm going to get a loop that runs forever. All right? Or rather, it's going to run until my program crashes. And that's because I starts at 0, and I'm decreasing it by 1, and I'm going to keep repeating it as long as I is less than 25. Well, I is always going to be less than 25. All of these numbers that are popping up down here in my output, those are all definitely going to be less than 25 because we're never increasing it. So please make sure you're paying close attention to your conditional and how it's going to react to the other two sections of your code. If I wanted to create something that was maybe a little bit more useful, I might start I at 100 and keep repeating it while it's greater than 25. Perfect. So it's going to look something like this. It's decreasing, and the loop's going to keep repeating while it is greater than 25. Okay? Now, 99% of the time when you create a for loop, it's because you want to repeat the same amount of code and you want it to happen X amount of times. So although you can change the first and the last section, 90% of the time it's going to look like that. It's going to start at 0 and you're just going to increase it by 1 every time as a traditional counter. So keep that in mind, but also know that you can alter it to create unique scenarios. Okay, one last thing, besides the fact that I have 2 lines of white space down here, don't do that. Only ever have 1 line of white space. Is that just like with if statements, with the loop, if there is only 1 line of code contained within the loop, you don't need those brackets. Okay, if you take out your curly brackets, it assumes that there is only 1 line of code in your for loop and it will only use that 1 line of code. But you can only do that when there's 1 line of code. As you can see, this will run the exact same as our original program. Okay, so an interesting use of for loops would be in this program right here. Again, I'm going to run it and then we are going to analyze it. Okay, so it's a multiplication game. Let's practice our timetables. Answer the following questions correctly to win the game. How many questions do you want to attempt? Well, let's say I want to attempt 3 questions. So what's going to happen is I'm going to take the user input, which is 3, and I'm going to have a for loop which is going to run 3 times because I only want to ask the user 3 questions. All right, the first question is what is 10 times 7? That's going to be 70. Okay, and I am using random numbers to create these questions, again giving my multiplication game some replay value because they're getting different questions every time. Each question is going to multiply 2 random numbers between, I believe I had it between 1 and 12. Okay, so question 2, 5 times 11 is 55. Question 3, what is 10 times 10? 100. Congratulations, you have beaten the game. Now if I was ever to accidentally get a question wrong, for example, what is 8 times 4? Let's say it's 20. It will say wrong, you got 1 answer correct, and it won't ask you the rest of the questions. It'll simply kick you out of the program and say we're done with you. So let's take a look at my code for how this happens. First of all, I have my scanner to take the user input. Second of all, I have a variable which keeps track of the amount of questions I want to ask, which I will be getting through the user input. I have num1 and num2, which are both going to be random numbers between 1 and 12, the 2 numbers which I create the questions out of. I have the correct answer, which I'm going to calculate internally, and I have the user guess, which I am naturally going to compare to the correct answer. I start off by printing an introduction, explaining how the game works, asking the user how many questions they would like to attempt, taking that input and placing it in queue amount. I'm going to have this giant for loop, which runs for between the highlighted brackets down there and up here. This for loop is going to start at 0. It's going to increase by 1 using my I counter, and it is going to keep going while I is less than the amount of questions that the user inputted. So it's going to run that many times that the user inputted. Each time this for loop runs, each iteration of this for loop is going to present 1 question to the user, take their input, and compare it with the correct answer. If it is correct, they will move forward to the next iteration. Otherwise, we will leave the loop because we don't want to ask them any further questions if they get 1 incorrect. So you guys should already know how to create random numbers. You should know that this line of code down here creates a random number between 1 and 12. I'm going to create 2 random numbers between 1 and 12 and internally calculate the correct answer by multiplying these 2 numbers together and placing it inside a variable a and s. Now that I have the question, I'm going to present it to the user. Question number I plus 1. Why do I do I plus 1? Well, I starts at 0. And I don't want to say this is question number 0. It's more user-friendly to say this is question number 1. So I take I and I increase it by 1. So I start at 1 and I end at 12 instead of starting at 0. Sorry, I start at 1 and end at the maximum amount that the user inputted instead of starting at 0 and ending at 1 less. So question number one, I present the user with the two random numbers that I created, ask them to multiply them together, and take the user input. And then there are two possible scenarios. If the user was correct, if the answer is in fact equal to the guess, then I will print out correct. If it is wrong, I will tell them that they are wrong. I will present to them with the number, the loop iteration that they were on, because that's the number that they've gotten correct, conveniently enough, and I will force exit the program. If they get through the entire loop, getting all of them correct, then I will present a congratulations statement, and then I will end the program. So please make sure that you're practicing with for loops, and let me know if you have any questions.